In this video, we are going to talk about compound angles. Okay, now this is the third video on trigonometry that we are dealing with. Okay, we've explained the introduction, we talked about special angles, and if you've not watched this video, I ask you to at least watch them. You gain insights on the introduction to trigonometry or what we have done, so that anything that we mention here, which has been taught in the previous video, it will not be news to you. Okay, at least you know what it is, and then you'll be able to work with us. Okay, now here is compound angles, or rather I'm going to call it sum and difference of angles. Okay, sum and difference of angles, that's what we're going to call it. This simply means we are taking the sum or we are subtracting angles. What are we going to get in that case? Now you might be thinking, if we have cosine of theta plus phi, okay, it is equal to cosine theta plus cosine of phi. God forbid this is not correct. Okay, if you are thinking this is correct, please change your mindset. That is very, very wrong. Okay, cosine of theta plus phi is not equal to cosine theta plus cosine phi. That is not how it works. Okay, in trigonometry, in algebra you might be having y into bracket x plus z, and then you expand it to work. But in trigonometry it doesn't work. Okay, things are quite different. And what will not be the actual form of writing this? Okay, we are going to prove the first one, which is this. We're going to prove this, and then for the other ones, we're going to follow up with just bringing out the formulas. Okay, so that is what we are going to do. Okay, so to prove this out, I'm going to first of all draw a diagram and bring out a few expressions. So I'm going to draw something like this. Please take note that the diagrams are not being drawn to scale, okay? Or we are making an assumption. So draw something like this, and then like this, okay? And then now this way, here is perpendicular to the other end, okay? These two lines are perpendicular. That's why I say they are not drawn to scale. But if you make use of a ruler and it's straight, this is what we're going to get. And then I'm going to call this angle theta. I'm going to call this angle phi, so that if you find the cosine of the whole angle here, it becomes theta plus phi, which is our aim. Okay, now let's look at our diagram. We'll call here A, we'll call here B. Let's call it C, D, E, F, and G. Now, before we proceed to start solving for the value of cosine theta plus phi, let's see if we can make use of some assumption, of which one of them is telling us that here is 90 degrees. Okay, F, G, and C, D, they are equal in length. Okay, take note of that as well. Now, if here is theta, here is 90 degrees, you can see that these two angles are the same, right? Now, if here is 90 degrees, it means the inside is also 90 degrees. Now, notice that vertically opposite angles are equal. Okay, vertically opposite angles are equal. So for this triangle EBD, this whole triangle should be similar with this triangle in the angles. Okay, here is 90 degrees, here is 90 degrees, here is equal to here, which means the last angles need to be equal, right? For the similarities of triangles, that means if here is theta, here has to be theta as well. So I'm going to call here what now? Theta. I think that's all we need to do. Now we can now work with what we have on the board. Okay. Now first is first, we have to find cos theta plus phi. To solve for cosine theta plus phi, cosine theta plus phi. Okay, in bracket. Now cosine theta plus phi, to solve for it simply means we are taking everything here. So that's adjacent to our hypotenuse, abi? So here to here is the opposite, here to here is the adjacent, here to here is hypotenuse. So here to here, we're going to have AF over hypotenuse is AB. Okay, that's the first step. Now we can choose to expand this further, of which AF is here to here, and that is the same thing as AG minus FG, right? So we have AG subtracting FG divided by AB, okay, divided by AB, yeah, remains the same. Okay, next things, we're going to try and relate all of these with this other triangle and see what the outcome becomes. Okay, And then from here, we can as well try to split. Okay, if I should split that guy, it gives us AG over AB minus FG over AB. Okay, now what's the next thing? We are still not done with the proof. Let's see how we can relate this AG with something else. Okay, first of all, where is AG? AG is from here to here. Okay, and let's see what we're going to get. Now for this next triangle we're having here, okay, let's see what we can work out AG and get. Okay, so for AG, we can make use of cosine of this angle. We can say that cosine theta is adjacent over hypotenuse, right? That's AG over AD. That's AG over AD, of which you can then say AG is equal to AD cosine of theta. Okay, that's one thing. Okay, and then how about FG? FG is same thing as CD, right? Same thing as CD. That's FG. Remember here is 90 degrees. Okay, so note that FG is equal to CD. So from this triangle, this small triangle we're having here, we can as well find sine theta. In this case, sine theta now becomes FG or CD. Okay, sine theta is opposite of hypotenuse, so we have CD over BD. So that's what now? CD over BD, of which CD we just prove that it's the same thing as what now? FG. These two guys are of the same length. So we have FG over BD. So we can now say FG is equal to BD sine of theta. Okay, take note of these two guys. Next, we're going to substitute that equation 1 and equation 2 into this formula. Okay, so when we substitute, we're now going to have cos theta plus phi. Okay, and then to be equal to AG was just proven to be AD cosine of theta. So we're going to have AD cosine of theta, okay, over AB minus FG is what? BD sine of theta over AB. So we have BD sine of theta over AB. Okay, now trust me, you do not want to mess with this cosine theta and sine theta since we've already proven something else. What we want to try doing is AD and AB and BD and AB, and so we'll get. Now for AD and AB, let's see what this gives us. AD, this is AD, and this is AB. Now if you take a look at this triangle again, this upper triangle, this whole triangle, AD is the bottom, okay, and AB is the hypotenuse, while BD is what now? Another side, which will be opposite or adjacent depending on the angle I'm making use of. Okay, so if we're having AD over AB, here to here is AD over AB, and if we are to deal with this angle, of course this is the only angle here. If we are dealing with this angle, which is phi, it means cos phi will be adjacent over hypotenuse. Okay, so AD over AB, I can write, let me write it up, but cosine phi is adjacent to hypotenuse, that's AD over AB, and then again BD over AB. What do you get for BD over AB? BD over AB, that's opposite over hypotenuse, right, which is sine. Also, sine phi is BD over AB. BD over AB. Okay, it is that easy. Okay, next thing, we want to substitute all of that into this equation. So we're then going to have cos theta plus phi is equal to AD over AB is what? Cosine phi. So we have cosine phi, okay, times cosine theta plus, okay, that's a minus instead, minus BD over AB is sine phi times sine theta. So you have sine phi times sine theta. Now that is the proof. Which means if you have, for example, cos theta plus cos phi plus phi, it is not expanded as this. Instead, here is the formula we're going to use. Now, like I said, this is the only one we're going to prove. This serves as an intro. The other ones, I'm going to just write them out. So all you have to do is take note of them and then you learn them. It is that easy. Okay? So I'm going to start again and write them out. First one is, if we have cosine theta plus cosine phi, it is equal to cosine theta times cosine phi minus sine theta times sine of what now? Phi. That is how it is being done. Okay? And then cosine theta, okay, minus phi. In this case, when we're having a minus, all we have to do is change this one. So it becomes cosine theta cosine phi plus sine theta sine of what now? Phi. Okay? And then the next one becomes sine of what? Theta plus phi. That will give us sine theta cos phi plus cos theta sine phi. Notice the difference. For sine, we are having multiples of sine and cosine, but for cosine, we are having cosine first, followed by sine. That is the difference. Okay? So you find the trick that you use in memorizing these things. And then for sine theta minus phi, all these they have proof. Okay? But you don't expect me to prove every one of them, or you can't say you want to be proving every one of these in an examination board. As it will take time, all you have to do is know these ones. Okay? Sine theta minus phi is now sine theta cos phi. Okay, this is the minus, so this one remains minus cos theta sine phi. Now we just did one for cosine and sine. How about tangent? For tangent, there's also a proof, okay? But I think this space will be too small for me to do that. And like I said, you don't have to start doing this in an examination. All you have to do is take note of it. So in this case, we are going to have tan theta plus phi to equal. Now what is tan theta plus phi? That is 1 plus tan theta. Okay? No, rather, this should be tan theta plus tan phi, okay, tan theta plus tan phi over 1 minus tan theta tan phi. And then for the negative one, tan theta minus phi. Now this will be equal to tan theta plus tan phi, okay, over 1 plus tan theta tan phi. That is the only difference. Okay, so here are the formulas. Now I'm going to take one quick example on the use of these things. So imagine we are having cosine theta plus minus phi. How do we work with this? What is the use? Now we can use that to find some sets of angles that are not special angles. In our previous video, we talked about special angles, okay, and how useful they are. Since we already know special angles, we can now involve some of them to find these things. Okay, now let's say for example we are to find the value of cosine of 15 degrees. Okay, what will be the value of cosine 15 degrees? How are we going to find it? To find the value of cosine of 15 degrees, we can make use of this formula. Here is how we're going to do it. We know that cosine 15 can be written as 45 minus 30 degrees. This will give us 15 now, right? 45 minus 30 is 15. So if I apply this formula, I can find the value of cosine 15. Now let's see what it's going to give us. So this now becomes cosine what now? Cosine 45 cosine 30 plus sine 45 times sine of what now? 30 degrees. Now what is cosine 45? Cosine 45 is something we proved in our previous video in short form. Cosine 45 is 1 over root 2, okay, and then multiply by cosine 30. Cosine 30 is root 3 over 2 plus sine 45 is 1 over root 2 multiply by sine 30. You are going to get sine 30 is 1 over 2. From here, this will give us root 3 over 2 root 2 plus 1 over 2 root 2. Okay, LCM is 2 root 2, and then we'll have root 3 plus 1. You can then rationalize, multiply by root 2 over root 2. So this gives us root 2 in brackets, root 3 plus 1. Okay, divided by root 2 times root 2, that's 2 times 2, gives us 4. So this is root 2 times root 3, that is root 6 plus root 2 all over 4. Okay, that is the value of sine 15 degrees. Okay, let's cross check to make sure there is no error in it. 45, cosine 45 is 1 over root 2 or root 2 over 2, same as sine 45. Sin 30 is 1 over 2. Cos 30 is 3 over 2. Okay, so when you multiply, you get this, multiply, you get this. LCM, the same thing. Okay. This is the LCM. From here, we rationalize, multiply the top and bottom by 2. Okay, this gives us 4. Okay, so we are good to go. That is an example, a quick example for for the use of these guys. Okay. Also, we are giving some examples on trigonometry. Okay, you might not be able to solve them using the normal trigonometrical formulas we have, which is sin square theta, cosine square theta. These ones will come in hand. Okay, these ones now prove what now useful. Now, this is the third video of trigonometry. I'm sure you guys will be following through from the first to the last, of which will give you a good understanding of it. Now, in our next video, we're still going to talk about how to convert from degrees to radians. Sometimes you are required to convert from degrees to radians, also in minutes and seconds. If you are given, for example, 20 degrees, how do you convert 20 degrees to minutes? Okay, you know all this have to do is your wall clock, okay, your analog clock, not your digital. Okay, we're going to talk about that. And we're also going to talk about some other formulas that are used in trigonometry. We have the double angles, we have multiple angles, we have product angles, and all these we talked about in the next video. So do what to like, share, and subscribe, like I always say. Okay, this will give you an insight on what we are talking about. Okay, and then of course click on the notification bell. That one is always important, so you get notified when these videos are being posted, and you can as well share again with your friends. Okay, that will be all for now. See you in the next video.